And these are the chapter 9.5 notes, solving trigonometric equations, page 5. This problem gets its own page, mostly because it's more fun than the previous examples that we had. So let's take a look at this. We want to solve this equation. We've got cosine squared theta plus 3 cosine theta minus 1 equals 0. Again, I can rewrite this with x equal to cosine theta. And so this becomes x squared plus 3x minus 1, which I would much rather look at sometimes than the cosine and the cosine squared. So now I need to take a look and see if I can factor this. And here's my problem. Only way to get 1x squared is x times x. Only way to get -1 is 1 times -1, and there's no way that I'm going to be able to multiply those in any way to give me a 3x. So I know I cannot factor this. So now we're going to go back to the quadratic formula. Okay, and that says for any quadratic, my solutions will be of the form -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Just as a reminder, in my quadratic here, x squared plus 3x minus 1, here's my a, here's my b, and here's my c. And I tend to always write those out, that way I don't make any mistakes plugging anything in. Okay? So I know my two solutions are going to look like this. X equals negative, b is 3, plus or minus the square root of 3 squared minus 4, a is 1, c is -1, and that is all over 2 times 1. Gives me a -3 plus or minus the square root of, I've got 3 squared, which is 9, minus 4 times -1, so minus -4 plus 4. Gives me a 13 in here, all over 2. Okay. So here's what we got. I got cosine theta equals either -3 plus the square root of 13 over 2, or cosine of theta equals -3 minus the square root of 13 over 2. Now you'll notice when you plug this second one in, you get an error. So square root of 13, that's going to be somewhere between 3 and 4. So even on the low end, -3 minus 3 would give me a -6 over 2, which gives me cosine theta is -3. That lies outside my acceptable range for cosine. So I know this value is not even possible. Okay. So you do have to check both of these. So let's take a look at the other one. If cosine theta equals -3 plus the square root of 13 over 2, that means inverse cosine of -3 plus the square root of 13 over 2 has to equal theta. So I'll go inverse cosine of -3 plus the square root of 13 all over 2. And I get to 4 places, 1.2632. Okay, so there's my theta. Now, here's the thing. If we take a look at the unit circle, this 1.2632 somewhere up here in the first quadrant, right? Because pi is 3.14 radians. That means halfway is 1.57-ish radians. 1.26 is going to be somewhere in here because it's less than 1.57. So my cosine is positive there. I also need that this way, negative 1.2632. It would be nice if I could list my solution as negative 1.2632, but notice that that would not fall within our parameters there. I got to be between 0 and 2 pi, and going negative is definitely not in that interval. So to find the second value, or our second solution, we're going to go back to what we know about coterminal angles. I'm going to subtract that from 2 pi. And I get 5.02. Okay. And since I want my solutions just on this interval, my thetas are 1.2632, 5.02. Both of those are between 0 and 2 pi. And so we're done.